Toyota is the king of reliability, a brand built on the forever car. But as a carchaeologist, I've been digging through the blueprints, and the truth is much darker than the marketing suggests. While most of these engines will outlive you, one specific family on this list is a mechanical ticking time bomb that Toyota spent millions trying to hide. We are excavating the entire lineage today, from the unkillable iron blocks of the 60s to the corporate disasters of the 2000s, and the high-tech, high-stakes gambles of 2026. This is every major Toyota engine family explained. We begin our dig in 1949 with the F-Series. This is the ancient ancestor. If you ever wondered why the Land Cruiser became a legend, look here. This was a massive, overhead valve straight six made of heavy cast iron. It was actually based on an old Chevrolet stovebolt design, but Toyota refined the metallurgy. It was produced for 43 years without a major architectural change. It didn't rev high, and it certainly wasn't fast, but it produced peak torque at just 2,000 RPM. This engine established the Toyota standard. Heavy, slow, but physically impossible to kill. You don't rebuild an F-Series, you just clear the debris and keep driving. Moving into the 50s and 60s, we find the R-Series, specifically the 22R and its fuel-injected brother, the 22RE. This engine is the reason the 80s Toyota pickup is now a $30,000 collector's item. It featured a dual-row timing chain in its early years and a block so thick it could handle decades of abuse. The archeology of this engine shows a design focus on cooling and oil flow over everything else. It only produced about 110 horsepower, but because it was so understressed, it became the benchmark for reliability. If the world ends, a 22RE will be the last thing still idling in the wasteland. By the mid-60s, Toyota wanted to prove they could compete with Europe. Enter the M-Series. This was Toyota's first luxury straight six. The 3M variant was actually developed with Yamaha, a partnership that would define Toyota's performance future. This engine powered the legendary 2000 GT, Japan's first true supercar. It featured a beautiful aluminum head and hemispherical combustion chambers. Later, the M-Series evolved into the 7M GTE found in the MK3 Supra. However, the 7M introduced the first major crack in the armor. A factory torque spec error on the head bolts led to widespread head gasket failures. It was a lesson Toyota would take to heart for the next generation. In the 80s, we see the rise of the S-Series. This is the 3S GE and the turbocharged 3S GTE. This was a 2-liter 4-cylinder that defied physics. While the 2JZ gets all the movie fame, the 3S GTE was the one winning World Rally Championships and Pikes Peak. It used a square design, 86mm bore and stroke, which made it incredibly balanced. The blocks were cast iron and the heads were once again tuned by Yamaha. This engine proved that Toyota could dominate motorsports with a small, high-pressure displacement. It survived 5 generations of development, eventually reaching over 250 horsepower in factory trim, a massive number for the time. Now we reach the golden age, the JZ. Specifically the 2JZ GTE. As a carchaeologist, looking at a 2JZ block is like looking at a pyramid. It shouldn't be that strong, yet it is. During the Japanese bubble economy, Toyota's engineers were given a blank check. They created a closed-deck cast iron block with oil squirters for the pistons and a forged crank. On paper, it made 276 horsepower due to the gentleman's agreement, but the architecture was designed for 600. It is perhaps the most over-engineered consumer product in history. It wasn't just an engine, it was a statement of industrial dominance. Parallel to the Supra, Toyota was building the UZ series for Lexus. The 1UZ FE was a 4-liter V8 that Toyota spent over $1 billion to develop. They were so obsessed with vibration that they used a 6-bolt main design, a feature usually found in racing engines. This is the engine from the famous commercial where champagne glasses stay perfectly still on the hood at 140 miles per hour. It is one of the few engines in the world with multiple documented cases of reaching 1 million miles on the original block. It represents the peak of analog reliability, before sensors and plastic parts took over. As Toyota moved towards front-wheel drive, they needed V6s. First came the VZ series. These were heavy iron block V6s used in trucks and the early Camry. They were reliable but mechanic unfriendly. Because they were originally truck engines, they were very tall. To fit them in a Camry, Toyota had to tilt them 15 degrees towards the firewall, making a simple spark plug change a 3-hour nightmare. Then came the MZ series, which transitioned to aluminum to save weight. The M1Z FE was a great engine, but it introduced a new enemy: engine sludge. Because of narrow oil passages and high operating temperatures, if owners didn't change their oil exactly on time, the oil would turn into a thick gel, destroying the engine. This was the first sign that Toyota's new, tighter tolerances required more care from the average owner. Now we enter the dark era of the early 2000s. Toyota was chasing global volume, and quality slipped. The 1ZZ FE and the 2AZ FE were disasters for the brand's reputation. The 1ZZ had a defect where the piston rings would clog, causing the engine to burn a quarter of oil every few hundred miles. The 2AZ FE was even worse. The head bolt threads in the aluminum block were too weak. They would literally pull out of the metal, causing the head to lift, the coolant to leak, and the engine to melt. Toyota eventually had to offer massive warranty extensions, but for many owners, the Toyota reliability myth was officially broken during these years. To save themselves, Toyota launched the GR series. The 2GR FE 3.5-liter V6 is arguably the best engine they've made in the last 20 years. It solved the sludge issues, used a rock-solid timing chain, and was so reliable that Lotus used it in their supercars. It features D4S dual injection, which uses both port and direct injection to keep the intake valves clean of carbon buildup, a problem that kills most other modern engines. If you buy a Toyota V6 today, this is the one you want. It is the bridge between the old-school durability and modern efficiency. As we move into 2026, we see the dynamic force family, the A25AF. This is a marvel of future archaeology. It achieved 41% thermal efficiency, a world record for a mass-produced engine. It uses laser-clad valve seats and ultra-high compression ratios to get incredible fuel economy. However, as a trade-off, these engines are incredibly complex. They use electric water pumps, electronic thermostats, and variable oil pumps. We don't know yet if these smart parts will last 30 years like the dumb iron blocks of the past. Finally, we reach the present-day crisis, the V35A FTS. This is the twin-turbo V6 found in the new Tundra and Lexus LX. This is the ticking time bomb. In late 2024 and 2025, Toyota issued a catastrophic recall for over 100,000 of these engines. The ghost files from the factory revealed that machining debris, tiny metal shavings, were left inside the engine during the manufacturing process. These shavings would circulate through the oil and lodge themselves in the #1 main bearing. Under the high pressure of twin turbochargers, the bearing would seize, leading to total engine failure, often with less than 20,000 miles on the odometer. Toyota is currently replacing thousands of entire long blocks at a cost of billions of dollars. It's a reminder that even the most legendary brand can be humbled by a simple failure in cleanliness. Toyota's history is a map of incredible peaks and sudden corporate-driven valleys. From the overbuilt iron blocks of the 22R to the high-strung, debris-filled turbos of the today, the brand isn't a god, it's a manufacturer. They are capable of building the best engines in the world, but as we've seen, they are also capable of massive mistakes. The archaeology shows that the simpler the engine, the longer the legacy. But if you want to see how Toyota's biggest rival, Honda, handled their own engineering scandals, you need to click here for our next excavation. I'll see you at the next dig.